Okay, so today we're going to be talking about two very powerful features in Python. These features are tuple unpacking and list comprehension. So let's take a look at what these two things are. So what is tuple unpacking? Well, tuple unpacking allows you to sort of combine values into this one statement as a tuple, the tuple data type. And then you can, what's known as unpacking, you can unpack the tuple into separate values later on. And we'll demonstrate how this is done through code in a moment. It can be used in many places, tuple unpacking, and it's very, very useful. What's important to note though is that tuple unpacking isn't some hidden feature, some extra feature in Python. Everything that you can do with tuple unpacking, you can be done without. However, tuple unpacking just makes it a lot more simple and more convenient. It's simply a way to write shorter code and a way to take advantage of tuples. So how does it work? Well, the basics of tuple unpacking is that you can assign values to variables directly from a tuple. So here, what we have here in this image are three variables, x, y, and z. And we have this tuple with three elements, 12, -6, and 3. What Python will do is when it sees a tuple, it will unpack the values one by one into the corresponding variables. So 12 goes to x, -6 goes to y, and 3 goes to z. Note that if you had just one variable, it would treat it as a tuple itself. And this is why when we print x, we get 12, when we print y, we get -6, and when we print a z, we get 3. But note that this also, an issue with this is that what happens if the number of variables does not match the length of the tuple? So for example, in this image, x comma y is equal to the tuple 12, -6, and 3. Python will attempt to unpack this tuple. The 12 will go to the x, the -6 will go to the y, but the 3 has no variable to go to. And so Python will give you an error, and it'll say something along the lines that there are too many values to unpack because there are too many values compared to variables. Similarly, in the second line, w, x, y, z, here we have 4 variables, but only 3 values in the tuple. So what happens if we try to unpack this? Well, Python will unpack the 12 into the w, the -6 into the x, the 3 into the y, but then there's nothing to unpack into the z. And so again, Python will throw an error and tell you that there's something along the lines of there are too few values to unpack. So these are two common error messages you'll see when dealing with tuple unpacking. So this is the basis of tuple unpacking. You can directly kind of unpack or expand a tuple into individual values. But how is this actually useful? Well, what you can do is you can sort of emulate multiple return statements. So if you know, the return statement in Python will exit out of the function. And so you can only technically return one value. But what you could do is you can combine all the stuff you want to return into a single tuple. So in this case, let's say we wanted to return 3 variables, text, a number, and a list. What we could do is we can combine them into this tuple, which has 3 things, text, number, and list. And you can return this tuple as a whole. And then later on, you can unpack them individually. And what's important to note, once again, I'll reiterate, that everything that can be done without tuple unpacking, or everything that can be done with tuple unpacking can also be done without it. So for example, we can, instead of assigning multiple returns, which is this function we declared, instead of assigning it and automatically unpacking it into 3 variables, my text, my num, and my list, what we could do is we can assign it to this variable called my tuple, and by using indices, access each element and assign it. So as you can see, this would work exactly the same way. But this, in my opinion at least, this first way is a lot cleaner, a lot shorter, and it's more visually appealing. So both ways do work, but this is where you can really leverage the power of tuple unpacking. Another way that could be useful is something along the lines of coordinates. Let's say you are dealing with a number system or a coordinate system where you have 3 points, x, y, and z. What you can do is similarly have a multiple return statement where you return x, y, and z all as a tuple, and you can unpack them into their separate variables. This is similar to what we showed in the previous slide. Also note that in this first line where we do x comma y comma z equals 12 comma 15 comma 17, we don't actually surround the three values in parentheses, so it's not actually a tuple. What's important to note is that Python also supports multiple assignment, which means if you try to assign multiple values to multiple variables, Python will be smart enough to know that 12 goes to the first one, x, 15 goes to y, and 17 goes to z. But this isn't the case for, let's say down here, x comma y comma z equals, and then we call the function coordinate generator. In that case, since we return a tuple, Python will unpack it automatically into these three variables. Another way that's useful is to use tuple unpacking inside for loops. So one thing is, suppose we had a list of coordinates, building off of the example on the previous slide. Let's say we had a list of tuples, each having 3 elements, for example. So in this case, the first coordinate, x, y, z, is the points 12, 14, 6. The second point is -2, -1, 0. The third point is this, and so on. There are 4 points in this list. What we could do is iterate through the list of elements and access each tuple individually, and then access each element in the tuple using the indices. But right off the bat, it might be difficult to know what my tuple at index 0 really represents, right? Sure that since we wrote it, we know that it represents x, y, and z. But it would be nice if we could assign a name to the first index, rather than accessing it through this index. So we can do exactly that using tuple unpacking. For x comma y comma z in coords. So what Python will do is it will iterate through the list, and since each element is a tuple, Python will attempt to do tuple unpacking since we specify 3 elements, x comma y comma z. So it'll unpack 12, 14, and 6 into x, y, z for the first iteration. It'll unpack -2, -1, and 0 into x, y, z for the second one. And here we can access them individually. We don't have to have any of this index business. But again, this brings about an issue. What happens if the length of the tuples are different? So we had 12, 14, 6, and then maybe a fourth coordinate, 8. In that case, you will get the same error. The error we discussed in the first one, saying there are too few or too many values to unpack. So you need to be careful that your code is structured and that it's fixed length whenever you use tuple unpacking in for loops. And typically that is the case because having unstructured data is extremely difficult to work with. So a lot of time that will be the case, but it's just important to verify and make sure that you are in fact doing that. So when do you actually use tuple unpacking versus the other way, which is just simply doing accessing the indices? Well, tuple unpacking, like I said, is completely optional. It's simply a way to make your code neater. And the rule of thumb is that if you're dealing with multiple tuples or lists of tuples all of fixed length, then use tuple unpacking because it makes it a lot easier to iterate through them. It makes it a lot easier to access them. But typically you don't want to really use tuple unpacking for unstructured data that isn't necessarily fixed length or different types, all those different things. So that is a general rule of thumb of when you want to use tuple unpacking. Moving on, let's talk about list comprehension, which is another feature just like tuple unpacking. It's a feature that's completely optional to use. It's not necessary, and everything that you can do with list comprehension can be done without it. But again, just like tuple unpacking, it makes writing certain things a lot easier. It allows you to combine certain unnecessary lines into one line. Let's see how it works. Let's say we wanted to populate a list. And specifically, let's say we wanted to populate the list with the first 100 square numbers. So, for example, that would start off as 1, 4, 9, 16, 25, being 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, all the way to 100 squared, which is 10,000. Writing them out individually, like 1, 4, 9, writing that out individually is tedious and it's not smart. Instead, we've learned to use for loops. A for loop makes the code dramatically shorter. Here we're doing myList equals a new list. And for every element in range of 100, so essentially the first 100, we do myList.append and then I to the power of 2. Remember, double asterisk is not multiplication. It's to the power. Technically, what this for loop is doing is it's going from 0 up, not 1. But you get the idea. You could just add 1 to I, and you get the same behavior. Okay, so here we can use... so this for loop is a way of basically emulating the same behavior. And it's a lot shorter. But as you can see, there's a lot of boilerplate code. We define an empty list, then we iterate from a number to 100, and for each element, we append the square of whatever we're iterating through. That's something we do quite often. We could do it for just I. We could do it for something like the cube of I, a more complex function for I. And that can be a bit complicated. Or not complicated, but more tedious to type out every single time. So how can we do this using list comprehension? So list comprehension, the focus of it is to reduce the repetitive bits. So let's actually see how these two images map out. Here we define, in the first image, we define a list, we iterate from I to 100, and then we append I squared. Okay. Well, how does that translate to list comprehension? In list comprehension, you do everything inside the square brackets. And let's break it down. We want to do so how it's read is my list equals a list of all elements I squared for every I in range of 100. So what Python will do is it will evaluate I squared. But what is I? Well, I is defined for every I in range of 100. So it will iterate for every I in 100, and it will basically add I squared. That's what this is doing. That's the basics of list comprehension. The expression goes within the curly brace or within the square brackets, and then it just evaluates the expression. And these two map directly. And this is definitely a lot shorter. Okay, so like I said, the I squared corresponds to what we put here. Typo, this should have said I squared, whatever. And then we do for I in range of 100, which maps exactly for the second line. For I in range 100 maps the same for I in range 100. This is how these two map together. And this is a general, I guess, formula, if you will, that you can use to convert between a normal for loop to something like this. Here we have for I will correspond to the same for I. And in some value, some list, some generator like the range, anything. And it will basically just map 1 to 1. And then you have the formula you use, which is myList.append and something in terms of I. So maybe I squared, I divided by 2, whatever. And you would do the same thing here. This is how it maps out 1 by 1. But this is also still quite limited, because here all we can do is a single line of appending. We define a list and we can only have one append line. If we were to have 2 append lines, we can't really do this the same way. It doesn't work out the same way. So instead, what happens if we have an if statement? So if, let's say, if I is even, let's say we want to add 1 value. Otherwise, if I is odd, let's say we want to add another value. Well, list comprehension does allow for this. Here, if we have an if statement, so let's say we only want to add even numbers to this list. What you could do, a smarter way of doing this, would be to add a step to the range. However, that's not really I guess this is for demonstration purposes. So here we have for I in range of 100. If I is even, so that's what this mod 2 equals 0 does, only then do we append I. And mapping that to the list comprehension, the first part's exactly the same. I for I in range 100. But then we add an if clause. If I mod 2 equals 0. As you can see, it maps exactly. So it'll only add I for every I in 100 if I mod 2 is 0. And this will work exactly the same way. Okay. So now what happens if we have an if and an else statement? Well, with an if and an else statement, it gets even more complex. So here we have an if statement and then an else statement. And while in the previous slide, if you remember, the if clause came after the for I in range of 100, now it comes before, as if Python couldn't make it any more confusing. Now it comes before if I mod 2 equals 0, else odd. So here we define what to do if I mod 2 is equal to 0. So we do I only if I mod 2 equals 0, else we do odd for every I in range of 100. And as you can see, this is starting to look more and more cryptic. It's not really doing what we want. It is doing what we want. It does execute properly, but it's not clean. It's not neat code. It's very messy code, and it can be really, really difficult to read. So what do you want to use list comprehension? The rule of thumb is to use it sparingly. You only really want to use it for simple examples that have almost no conditional logic. The moment you're starting to use if statements and if else statements, you probably want to reconsider whether you want to do it using just a normal for loop like this. Because in my opinion, this for loop, although it's a bit longer, is a lot neater to read than this single line mess. And I personally think that writing neater code is better than writing short code. And remember, Python has this motto, I guess, that says beautiful code is better than ugly code. And what that means is that this code, I wouldn't really call it beautiful, but it's more neater, it's more easier to look at than this code, and therefore it can be considered to be less ugly. This code, although it's shorter, is more ugly, and that's not really what Python wants. It wants code to be clean, and other people should be able to easily understand it. Okay, so these are the exercises we've developed to test list comprehension and tuple unpacking. So the first one is to create a point class, which is 2D. You can make it 3D if you want, but this point has X and Y. What you want to do is you want to create a list of points with a random X and Y. So try to generate, there's I guess two parts, try to generate a random list of tuples with two values, X and Y. And what you want to do is you want to use tuple unpacking in for loops to find the perimeter of the shape formed by these points. So for example, if we have the points P1, P2, and P3, what you want to do is you want to calculate the distance from P1 to P2. You want to add that to the distance from P2 to P3, and then you want to add that to the distance from P3 back to P1. So kind of like this cycle. And if you need a refresher, this is how you actually calculate the distance. So suppose you have 2 points, points 1 and 2. What you do is you subtract the x component of the first point from the x component of the second, and you square that. You do the same thing for the y components, you square it, and you add them together. And then you take the square root of all that, and that'll give you your distance. So that's essentially what you have to do to calculate the distance between 2 points. The second exercise, using list comprehension, is to produce a list of tuples such that you have this. You have the elements 0 paired with whether or not it's even. Then you have the element 1 followed by odd, then 2 followed by whether it's even or odd, so on. So for example, the number 49 would be odd, and so on. And you can pick the ending number. Maybe a number like 100 would be a good place to stop. And then print it out and see what happens. Okay, then you want to create a list of square numbers. But if the base is odd, essentially, so for the numbers 1, 3, 5, 7, instead of adding the square, what you want to do is add the cube. So here we do 0 squared, then 1 cubed, then 2 squared, then 3 cubed, then 4 squared, then 5 cubed, then 6 squared, then 7 cubed, and so on. And you can pick an ending number again. I'd say a good place to stop might be 50, because you don't want to spend too much time with this. But these two exercises will test list comprehension in a way that makes it a bit entertaining and a bit fun. So that wraps it up for this presentation. If you have any questions, you can email us at internpy@codivate.org. Once again, reminder, if you want to be able to quickly talk to and reach out to your tutors, join our Discord at codivate.org/Discord. And if there are no questions, I will see you guys next week. Bye.